Okay, we are live with a bit of delay, I guess. Oopsie doo. My voice is going to be trash because I have my microphone boost at high level. Holy cow. Okay, that'll do it. So yeah, that does it. Alright. Sorry about that. Anyways, so today I'm going to do a bit of study before I. Alright, I'm going to do some study before I actually go about implementing some stuff I need. So I just asked the InfoForge Discord about an interface to wait on semaphores, something that I need. So let's break open the design I have in mind. So here we are good. I need to do some modification with my workspace here. Okay, that should be fine. So the design I have in mind is that there are two things I can be doing. One thing is to provide reader writer so reader writer synchronization. Like for example, if there are reads going on, I wouldn't want any writes to happen. The other thing that I would like would be to actually provide synchronization between CPU and GPU. To achieve the latter, I don't know how to achieve the first one, which is synchronization between a reader and a writer. So that is uh, not allowing anyone to write the resource when it's being read. I don't know how to achieve that. I'm just gonna trust that on the user, I guess, or maybe yeah that user could be the next layer of abstraction. Anyways, moving forward from that, I want to do proper CPU and GPU CPU-GPU synchronization. And the thing about that is, the way I wanted to do that, we have, I believe I added some extra code here yesterday just to show what I had in mind. Let's remove that. Alright, thank you Visual Studio for taking so long. Anyways, let me just remove these. Okay, these are the extra code I added to demonstrate what I had in mind yesterday. Uh, so the problem with what I'm trying to do is that if I wanna manage, like, let's say I wanna manage the use of my resources, alright? I wanna see if my resources are being used or not. And I'm aligning my resources to. So I got into a discussion with Wolf in their Discord, and that kind of got me thinking. Uh, so Wolf says that we don't really need semaphores for this kind of synchronization. He might be correct. The thing about this is that, let's say I'm either going to use a single resource in one queue, or I'm just going to use it in multiple queues. If I'm going to use it in a single queue, I don't really have to do uh, any kind of, I wouldn't have any worries on synchronization. So yeah, that is the problem here. So if I'm going to use a single resource with a single queue, everything should be fine. However, if I want to use that resource with multiple queues, that is going to cause problem. And that is where I need to like look for, let me see how I can actually demonstrate this. Maybe I can draw something. Let's see. Let's open up the paint. So let's do this. Okay, let's say we have these two queues. I'm going to show queues by circles. Let's say we have these queues and not circle. Yeah, let's make them circles or make them arrows. Maybe arrows are better, or maybe not. Maybe whatever. Let's say I have this resource here. Okay, I'm gonna color resources red and I wanna fill it. Big solid. Uh, okay, that's a resource. Alright. Let's say I am gonna put this resource in this queue. And then maybe later I will decide that I want to also put this resource into another. How can I rotate this? I cannot rotate that. Let's change this. Let's use a single line. Or maybe, yeah, let's stick with, okay, that's our resource, alright? That could be a bunch of resources. Then I would maybe try later on to put this resource into another queue. Okay, so I need to now wait for both of these to signal me, okay, I'm done. Alright, and then I would be able to remove this resource. And I would need both of these to notify that they're done. However, if I actually don't have, let's say I don't have, so this issue here that multiple people are going to signal me, I need to aggregate their signals and make sure that everyone has actually signaled me that they are finished. So the design that I had in mind was to put a semaphore here, and this would be our semaphore, but it's still red. I want color blah blah. Okay, let's say this is the semaphore here. Right, I would copy it, pass the semaphore here. It would leave here. It would also leave here, and when the queues are done, they would signal the semaphores here, and that would be the next time that I would use these queues. I would figure out that those resources, or maybe when I want to delete those resources, I would figure out that they're not being used by the queue, so I would be free to remove this. That's what I had in mind. So I would remove this resource. However, if we're actually using a single queue here, then the synchronization is pretty simple because I'm always going to check on this. That is the problem here. If I always have a single queue and I know what I'm drawing, so Wolf says that uh, that you only need to you can figure out when a resource is not being drawn, when it is out of the scene. That is basically what he is trying to say. And then he's just he's I think uh, pre, he has the presumption that it is that we always have a single queue. So if you have a single queue, the object is not in the scene, and you've rendered the next frame. That means that you can actually remove the resource because the object has moved out of the scene, it's not there, so you remove it. However, if you actually have multiple queues, maybe you are still using it in some other queue. So I might be doing something that is actually not really needed. I'm trying to bind the lifetime of this object here with the use of queues. However, what he is suggesting is that someone up here sees the object, sees the queues, loads resources in, and removes them when necessary. And he knows about the relation of this object with these queues. That is what he is saying. So that would be the next layer of abstraction. I would need to wait on these queues. Maybe he's right. Maybe I don't really need that. Also, another question that rises here is that, let me see. So one thing that I believe this code actually does, why has Visual Studio gone completely mad at me? Why can I not open that up? Holy cow. Okay, let me restart this. This is definitely bugged out. Did it just get fixed? That got fixed. That was interesting. Anyways, so even though we have multiple commands, we're just trying to one at a time. So swap chain footer. That is a signal semaphore there. Let's see what we're doing there. There's a signal semaphore and the fence is null. Okay. And then we have this thing here. I want to see where this is used. Okay, the next thing that is being, the next place that it is being used is here, with sample. I don't understand this. I really don't. We are waiting on the swap chain here to tell us that the swap chain is ready. Then on submit we are waiting for the swap chain to be ready. I really do need to understand this shape to move forward. I have no clue at the moment. Like I want to, let's say I would like to assume that we are actually rendering, we're using a resource in one of these commands at a time. Okay, let's say that would be, so we would need to wait on either of these, either either on acquire, which only waits on the set command, or here, the signals that waits. So So hypothetically, a resource could be used in multiple. That is what I understand here. That a resource could be used in multiple graphics commands here. But this only handles the synchronization between render target and drawing into the set render target. That is what's happening here. It says render target is ready, draw on it. And the submit here waits until the submit command waits until it's been signaled by this wait semaphore, then it submits my command into the queue, and here we wait for the queue to be done, then we present the image index, that is the render target that I want to present. So hypothetically, there are cases where one resource is being used in multiple queues, in multiple commands. However, they are all in one queue. What I originally wanted to do, mm, I wanted to have this signal semaphore here for each object that is being used by this command, and then the command would signal those objects that it is done using them. But if you have multiple commands, this signaling thing wouldn't work because one command could signal, yet there might be two other that are using it, and that is going to fail catastrophically. I'm trying to actually, I really want to actually model the model this lifetime, but I really don't have the tools provided to me by the interface really here. So the correct lifetime model that I would like to do, let's assume that we have all the interfaces that we want, alright? So this is what I want to do. Let's say we have this resource here, okay, and then we want we want to do some stuff then. Alright, we have these commands. They could be associated with multiple queues here, with different queues here that is associated with other queue. Right, so what I would want to do would be, okay, I'm going to use this here. Alright. Now this bounds my lifetime to this queue. This queue is usage only. Okay, let's say that this would give me a token, and now that I have this token, I would use, I would need to wait on this token before actually deleting this or removing. So this object's lifetime is bound to this token. Same would happen if if I were to use this resource in this command. Same thing should happen. I would be given a token here, and then I would wait on this token, and then I would be able to remove this. Okay. The fact that whether I want to actually or don't want to remove this resource would come from above. Like someone would say the resource is no more inside any of the viewports we have, so that means you can actually remove this resource. So remove it. That decision would have to come from above. Then I would try to remove it, but I still need to wait on these. So that is what I want to do. And one way of doing that would be that this resource would be a shared pointer. Okay. If that resource is a shared pointer, I would move this, make a copy of this shared pointer into these tokens. Maybe into these queues here. And then the above layer could actually remove that without any worries, and these queues would remove whatever that they've used previously when they are done actually using the resource. So that would be a proper way of modeling this. However, you would need to actually pay for those shared pointers. Those shared pointers do not come without a cost. So on each call to a command, you would actually make a copy of that shared pointer, which is a copy of two pointers to be specific. So that is 64 bits copied. However, that does cause a reference increment, and then after each draw you would decrement the same reference. So then also there would be this thing like something like there could be something like bundling. So you could bundle few resources here. So you would bundle these resources. There would be a shared pointer in this bundle, and you would have a shared pointer of this bundle here. So you would have a single share pointer for multiple things here. And then when also you would need to have this bundle inside the render. So the render would decide that if the upper layer of abstraction would decide that it is done with this bundle. So the bundle would still live inside these. When these decided to destroy the bundle, they would destroy the bundle. And if the reference count is 0, then so would be the lifetime of bundle. And that would not, and that would only require one fence. The interface that we already have would help with that. However, we are using then we would be using share pointers, and on each call we would have we would have, so yeah, you would have the lifetime of this bundle limited to the maximum lifetime of one of its members. You probably would be able to move objects from bundles within bundles, like move one object from one bundle to the other, so that way you would be able to maintain, like, cause one of the bundles to be removed, yet maintain the lifetime of the previous object. That would be one way of doing things. However, I do not like shared pointers. They cause complexity in code usually. The other problem we have is that our objects are not really free in their lifetimes. They are bounded to the lifetime of the render, and that is another problem that we have to deal with. Like, all of these moving objects from one bundle to the other, managing the lifetime, they would all have to be done inside the renderer, because as long as the render should be available before actually deleting these. So if the render runs out of the render's lifetime finishes before actually removing these bundles or whatever, then the code would be in a wrong state. The program would be in a wrong state because you have resources with no render associated with them. So that's another problem there. So let's say this canvas itself should be our render. Or maybe you could also just kinda rely on the user to manage that lifetime, which I don't want to do. So that is the whole thing here. That is what we're trying to do. I don't know. I don't really know. I don't think this shared pointer thing or the bundling is the correct thing to do here. One other way would be to limit one resource to a single queue here, single command. That way, you could actually move the object into the command, let it process, then move it out. That would be a simple design. But still, it would not be correct. Like, it would remove the ability to use a resource in multiple commands. So each renderer, for example, would have a command in it. Kinda. That is not nice. I still don't know what to do here. I really don't want to pay for the shared pointers here. These come with a cost. How do I bind the lifetime to the lifetime of object in GPU? That is a question we're trying to manage here. I think I'm going to suspend these series before until I actually come up with a proper design for that, and then I would be able to actually start implementing. I don't think these kind of design sessions is really interesting to the audience. So yeah, and I think I'm going to end this stream halfway here. Once I actually manage to come up with a good design. This is not a good design. This is a shared pointer jungle here, kind of object pulley. This object pull like it isn't really nice. So yeah, that's what I'm going to do. So I guess that's it for today. Today's episode is going to be short, 30 minutes only. And that is because I don't think you are really interested in seeing me design this. And I will suspend the series for now. I will come up with a new design, or maybe I would make a new series on this. Come up with a proper design and start over. I need to manage this lifetime in a proper way. However, the code for now works and is alright, I believe. So I may also commit this into my GitHub, so you can actually access that. If I did so, I would provide the link to my GitHub in the description. Anyways, I guess that's it for today. See you as soon as I come up with a proper design. I'm not making any promises here. I will try to come up with a proper design and then I will join back, maybe in a new series. See you.